All right. So, good afternoon. We're going to go ahead and start our lesson this afternoon. Well, it's not even afternoon yet, but it is lunchtime. So, for those of you guys that are coming in today, we are going to start our unit on the atom. So, what you guys see here is a part of my formula guide that I have on my website. So, if you guys are interested in getting a copy of this thing right here, it's very sturdy, it's tear resistant. This will be very helpful for you guys as you're taking your classes. So what I have on the board, let me go ahead and zoom out a little bit. Our lesson today is going to involve the atoms. And I know so many students are actually having to learn this information for their TEAS 7 exam. And for those of you that are having to take it, there are only 8 chemistry questions on the TEAS exam. However, with the 8, one unit in particular is this one here on the atoms. This is the unit that I would recommend and that you all study and know because it's very simple, okay? It's very simple. So if you're wondering what the atoms are, the atoms have 3 key components, okay? 3 key components. Number 1, atoms, of course, we know they're the building block, right? We know they're the building block of matter, but you can see these words all day, protons, electrons, and neutrons. But if I ask you to relate that to a real life situation, some of you all would be thinking like, well, how am I supposed to do that? So let me give you all an example. Everything that you touch, you breathe, you eat, you scrolling on your devices, they all exist because of atoms, because they behave the way they do as a result of atoms. Every time a nurse gives a patient medication, the nurse is trusting atoms they've never seen not to mess up. Now I'm going to pause for a moment and I'm going to let that sit right there. Because when we think about atoms in the healthcare profession, I think of it in terms of medication. So for instance, medications work because atoms form molecules that fit receptors like keys and locks. So you have sodium ions, potassium ions, calcium ions. They control heartbeats, muscle contractions, nerve signals. So if a sodium atom decides, you know what, I'm going to act the fool, your heart rhythm is going to go off beat. Okay? And so when we think about atoms in terms of healthcare, this is another example of why hospitals monitor electrolytes so closely. It's all because of these atoms. So when we talk about atoms, protons, electrons, neutrons, I'm going to also share with you how atoms actually help when it comes to your MRI or your CT scans. How? Because, of course, for those of you all that may or may not know, but your MRI uses hydrogen atoms to respond to magnetic fields. And X-rays, of course, interact with atoms based on bone versus tissue. And you know, CT scans rely on atomic density. So again, doctors don't see bones, they see how atoms react with energy when the energy hits them. So again, those of you all that are going into healthcare, these are just some examples of why it's important to know, yes. And I know you're probably thinking, well, I'm not going to see this in my real life profession in terms of having to ask the molecular structure of the medication. You're right, you don't. However, if you understand the background, it makes these questions a lot simpler to digest. So an atom consists of 3 main subatomic particles. You've got your protons. Those are positively charged particles found in the nucleus. So right here on my formula guide that I have, it's on my store if you all want to go and get access to it. This shows you here as a key example your atom. Right there in the middle, you have your protons and your neutrons, okay? That makes up the mass. And then around it, the busybody parts that are going around it, those are your electrons. So your protons are positively charged, your neutrons are neutral particles, and both of those first 2 things are found in the nucleus. But when we talk about your electrons, those are negatively charged particles orbiting the nucleus. Okay? Orbiting the nucleus. Now, as we scroll on down right here, I'm going to highlight some key factors that I feel you would want to know for your classes, especially those of you that are taking chemistry right now. So if you're taking General Chemistry 1 or a basic introductory chemistry class, this lesson is for you. Okay? This lesson is for you. Now, number one, when you think about the periodic table and how do you determine what is a proton, an electron, a neutron, you have to establish where these things are located. And it's quite simple. Okay? Matter of fact, before I go into this part right here, let me scroll here to the periodic table so you can have a better understanding of what I'm talking about, okay? So let me just zoom in a little bit so you all can see an example of an element on the periodic table. So let's take, for instance, iron, all right? Something that every woman needs more of during that time of the month, right? Okay? So as you look at this element here, iron has an atomic number of 26. So that number there, that number in the upper left-hand corner, that is the atomic number. And guess what else it is? It's the protons and the electrons. So think about a sweet pea. Okay, think about a sweet pea. Matter of fact, let me write this here so you all can see this. Think about a sweet pea, P-E-A. Protons, electrons, and atomic number are equal to the same thing, all right? Except for when you have ions, and we'll get into that in a minute. But what I want you all to do is to take a look at iron right here. You see that 26? That's the protons. That's the electrons. That's the atomic number. Now, when you look at this bottom number right here, that is the mass number, all right? That is the atomic mass number. So in other words, the weight that the element weighs is equal to that number with those decimals. And by the way, when you are dealing with neutrons, because you have to put all this together, I'm going to zoom out a little so you all can see this part. When you're dealing with neutrons, okay, you are going to take your atomic mass number and you're going to subtract that from your atomic number. And that will give you your neutrons, okay? That will give you your neutrons. So your neutrons are neutral, hence the word neutrons. And so therefore, putting these three numbers together is really easy. So when you guys get questions on your TEAS exam, and I'm asking you all, you know, what's located in the nucleus, you would say your protons and your neutrons. If I say what's on the outside as a charged particle, you would say your electrons. So again, when I tell you guys that you don't have to overthink this particular chapter, you don't have to overthink it. So on my formula guide, I'm giving you all the same information, but in a colorful fashion. So when you guys get this, if you all would like to order this, it has all the things that you need. And it's very colorful because I know I'm a color-coded person. I color code my notes. I tell my students to color code their notes so that it's easy to digest the material. So if I go back up here, okay, right there, I was telling you all that the atomic number is equal to the number of protons in an atom. Guess what else it does? It also identifies the element. So that atomic number is like the social security number of the element. It tells you the identity of that element. So if I look at carbon, carbon has an atomic number of 6. So therefore it has 6 protons. So you see, guys, you don't have to make this section hard. Where it gets a little confusing is when I have my students fill in charts of information. And all you got to do is look at two numbers. And those two numbers are going to tell you everything you need to know. Speaking of which, the next number is the mass number. That gives you the protons and neutrons added together. So the total number of protons and neutrons in the nucleus is equal to your mass number. So if I look at carbon, once again, element carbon, I know that 12 right there, that's the mass number from the periodic table. It has 6 protons and 6 neutrons. So the mass number is 12. Your electrons, that's a neutral, it's in a neutral atom. The number of electrons equals the number of protons. So let me give you all some examples of how to put all this together, okay? And again, I don't want you all to overthink this process, but what I do want you to do is to look at the information that's given and kind of go from there, okay? So let's say, for instance, we were looking at oxygen, okay? And thank you guys so much for tapping that screen. Let's see if we can get up to 1,500 likes, okay? Well, no, let's make that 1,600 because oxygen is has an atomic mass number of 16. So let's get up to 1,600 likes, okay? So tap that screen, tap, 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 tap. Now, when I look at oxygen, okay, as I mentioned to you all before, oxygen on the periodic table has an atomic mass number of 16, okay? It has an atomic mass number of 16. The atomic number is 8. So let me tell you what you're going to do with those two numbers. I can identify several things right here, okay? Several things with this. I know that the protons and the electrons mean the same thing, which is this number right here, 8. Because if you remember, like I said before, like a sweet pea, protons, electrons, and the atomic number all represent the same thing, which is the number 8. Now, when I look at the mass number, okay, the mass number tells me how much it weighs. But I also know that if I want to calculate the neutrons, I have to take the atomic mass number, subtract that from the atomic number, and I know that that's going to equal my neutrons. So in this case, 16 minus 8 gives me 8. Okay? It gives me 8. Now, if I were to tell you to look on the periodic table, matter of fact, we're going to do one together, all right? So here is, I'm going to zoom in. Let's zoom in. Let's look at silicon, all right? Right there. Can everybody see element silicon? Put the number in the box if you all can tell me what is the atomic number of silicon. Put your answers in the box, in the chat box below. Very good. Male inner healing. Very good, Mercedes. Very good. IBO. Very good, guys. Very good. All right. It is 14. Now, what else is equal to 14? Well, for element silicon, and matter of fact, let me highlight this element right here so you all can see it. This is the one that we're talking about right there, okay? We know that 14, very good, male inner healing, it is equal to the protons, exactly. So the protons is equal to 14. What else is equal to 14? In case y'all forgot, yes, good, electrons, good, Mercedes, good, Katia. Good job, good job, good job. So it's also equal to the electrons. And again, that's equal to 14 right there for silicon. Now, if I zoom in a little more, so y'all can see that, it looks a little blurry, but silicon also has a mass number of 28.086. Here's what you guys got to remember. Because it has an atomic mass number of 28.086, we're going to round that off to 28. Now, when we round it off to 28, I know that that's the mass number. I know that the atomic number was 14, but when I subtract those two, guess what I get? This 14 here is equal to the neutrons. All right? Do you all see that? It's easy, guys. It is easy. And we're just touching just those two. Okay, good. Good. And we're just touching the surface here. Now, let me switch on over to this side of town. Let's look at potassium. Right here. Potassium. See that number right there? Element number 19. And let me zoom in a little more so you all can see the mass number. Okay, now I love giving fun facts. Do you all know that some people have to take potassium to have muscle contractions? So let's say that you keep getting a Charlie horse. Your doctor may say, eat some bananas. Okay, eat some bananas. But sometimes you may have to take the supplement of potassium in order to get muscle contractions. Some people need that in their bodies, for a lack of potassium gives you cramps. Okay, so what you see right here, atomic number 19, that is equal to our protons. So let me zoom out a little so you all can see that. Okay, all right, so we got protons and electrons. So they both are equal to 19. Okay, they both are equal to 19. Yes, sodium potassium pump. That's right, avant-garde 90. Very good, very good. Now, if you look at the mass number was equal to 39.098. In chemistry, when we're trying to get the neutrons, we are going to subtract the 39 right there minus the 19, and we get 20. 20 is equal to the neutrons, okay? For potassium, 20. So y'all, if you see this on your test, do not overthink this. You're only looking at two numbers on your periodic table. The only way it would be 3 is if I talk about ions. Everybody put ions in the chat box. Ions. I-O-N-S. Ions. Now, ions are very helpful because it can change or alter the number of electrons that you have. So for instance, let me zoom out a little so you all can see this right here, okay? So that you all can see. I'm going to go ahead and erase some of this also, but let me go ahead and break this down for you guys so you can see exactly what I mean by ions. Now, let me tell you, ions are positive or negative. And the way you're going to remember this is think of it this way. If somebody is positive, okay, we're going to call them cations. But in chemistry, when it's positively charged, we actually will subtract, okay? We will subtract them. But when it's an anion, think about anion, that means negative, okay? So if somebody is always anti something, anions, that means they're negative. But that means we're going to add to that charge, all right? We're going to add to that charge. Now, here is the catch, though. To remember what they're equal to, I'm going to write them out up here at the very top. Majority of the periodic table is positively charged, okay? So group 1 has a positive 1 charge. Group 2 has a positive 2 charge. Group 13 has a positive 3 charge. Notice that I skipped groups 3 through 12 because groups 3 through 12 have multiple charges, and we ain't talking about them right now, okay? We'll get back to them later. Group 14 has a positive 4 charge, sometimes negative 4. 99% of what you guys will learn in chemistry, positive. Excuse me, guys. If I zoom over here to the next group, okay, see this group 15? It goes backwards like Aaliyah song, back and forth, okay? So in other words, it's going to go back, -3. Group 16, -2. Group 17, -1. And then that last group over there, y'all check it out, 0, okay? We're not even fooling with that last group. They're full. We'll talk about that part later. But the reason why I'm giving you all this right here in terms of those ionic charges is because when we get into calculating the electrons, that's the only thing that would change, okay? That's the only thing that would change. So to be clear on what I'm saying, let me give you guys an example. Aha. Okay, let me give you an example. I am going to, okay, right here. This is part of a worksheet that I have. So if you guys want it, you all can get it, you know, and I have this on my website also. But if you don't want to pay for it, you can screenshot, okay? But right here, electrons do change for ions. So if you have a positive charge, that means you are losing electrons. So even though it's positively charged, that means you subtract. And if it's negatively charged, that means you add. So if I say that you have a neutral atom, that means on my periodic table, when I see atomic number 11, that's going to tell me 11 protons, 11 electrons, because it has an atomic number of 11. However, if I say the sodium ion, because of that +1 charge, you're going to lose 1 electron. So that means instead of saying 11 electrons, I now have 10 electrons. I still have 11 protons. My atomic number is still 11, but the electrons is what changes. Okay? The electrons is what changes. Same thing. Oh, so let me show you all visually. All right? In case some of y'all are like, wait, say that one more time. I got you. Let me say it one more time so that you all can see this. All right, so I'm going to write it down right here in this space, okay? So, because even though it's here, I want you all to visually see it a different way. So the sodium atom versus the sodium ion, there is a difference. The sodium atom, we're going to go straight down the row, okay? So that you all can see this right here. The protons for the sodium atom on my periodic table, it has an atomic number of 11. Therefore, I have 11 protons. My electrons, I also have 11 electrons. Oh, thank you, Trixie01. Thank you. Oh, good. Well, I hope that this helps you for your TEAS exam, because there will be some questions like this on your test. And I actually have some questions that I'm going to ask you guys that are TEAS based. Okay, so yeah, just keep on watching me, honey. Keep on watching me. Now, the moment I say, well, what's up with my protons for a sodium atom? I'm sorry, for a sodium ion. Sorry, y'all. For a sodium ion. I'm still going to have 11 protons for my sodium ion, but you know what changes? My electrons. I initially had 11, but because of this +1 charge, it's like your checking account. You're going to subtract that $1 out, and that's going to give you 10 electrons. Your atomic number is still 11. So guys, the only thing that changes here are your electrons whenever there's an ion involved. So I'm going to say it again. The only thing that changes here are your electrons when an ion is involved. Now, if you all want to get access to this live, you go to my YouTube channel and I will be uploading this when we get off. Okay, so I have to wait for it to download and then I'll upload it to my YouTube channel, which is Learn Chemistry with Professor TK the Chemist. Okay, Ra, let me see your question. I like your name, Ra. So neutrons would stay the same as well? Aha, very good question. Very good question. Your neutrons will stay the same as well. So speaking of that, let's go ahead and put those down. So your neutrons is based on the atomic mass number rounded up minus your atomic number. So yes, your neutrons would remain the same. Thank you so much for asking that very good question. This is why I tell you all, participate in your class, ask questions from your professor or your teacher, even if you think, well, I better not ask that. No, ask them anyway, because you never know. Somebody else is thinking the same thing. You're welcome. All right. Now, let me show y'all chlorine. So you see this right here? Let's do chlorine. All right. Let's do chlorine. I'm going to leave this one here, but I'm going to scoop the screen down so that you all can see chlorine. Oh, and then we're going to hit this table right here. We're going to do the table. Okay. So let's do chlorine. All right. Chlorine. The chlorine atom versus the chlorine ion. All right, so check this out. We're going to do the protons, electrons, atomic number, and the neutrons. So we're going to do all of those right there, okay? So check this out. My protons are the same as my electrons, same thing as my atomic number. So if you look at your periodic table, and I know y'all like, look, Professor TK, I don't have no periodic table on standby. Say less. Y'all know I'm going to scroll to it so that you all can see it here, okay? So here is chlorine, right over here on this side of town. I want y'all to be familiar with this because you're going to need to know it, all right? So here's chlorine right here. See that? 17. What is the mass number? Can y'all tell me what is the mass number for chlorine? Round it up though. Put that number in the comment box, but I want you to round it up for chlorine. All right, good job, Avant-Garde 90. Good job. Let's see. Lil Cameo 954. Good job, Mercedes. All right, so they told you all it's 35. All right, so we get ready to rely upon them for this next part of our answer. All right, so let's go ahead and scoot on back down so we can get to this part right here. Okay. So they already told you that the protons was 17, electrons was 17, atomic number is 17. My neutrons, take that mass number, subtract it from your atomic number, and you get 18. All right? It's that simple, y'all. Whoops, sorry. Sorry, so y'all didn't see that part. My bad. Okay, so again, the protons is the same thing as the atomic number. It is also the same thing as my electrons. So PEA, like a sweet pea, all three of those numbers are the same. My neutrons is when I take my mass number, subtract it from my atomic number, and that's how I get 18. Now come on over here and let's do the chloride ion. Chloride ion, my proteins are going to stay the same. My electrons are going to do a switcheroo. I initially had 17. But guess what? Because of that -1 charge right here, in chemistry, we add. Whenever it's negative, you add. So think about it. If your checking account is in the hole by $1, you better add $1 to get it back. All right? To bring it back to balance. So in chemistry, whenever the charge is negative, you add. So therefore, I would have 18 electrons. My atomic number is still going to stay the same at 17, and my neutrons also will remain the same, which is 18. Okay? Y'all, this is not hard. This is not hard. So, we are going to do a quick quiz. Okay? So I got some quiz questions for you, and if you are ready, say ready. So I know that you're ready. You all know the phrase, stay ready so you ain't got to get ready. All right? So if you're ready, put ready in the chats. Thank you, Mercedes. This is how I am with my students too. I teach in a relaxing mindset. I make it relatable to everyday life because I know every student that walks in that door don't care that you like chemistry as much as anybody else. And here's why I say that. A lot of students are taking these classes to meet requirements, and they don't really understand the why. They just know I gotta take chemistry. But I want you all to fall in love with chemistry like I did. Okay? Now, I ain't gonna tell y'all it was an easy road, but I enjoyed teaching it because I know this is one of those subjects a lot of students dread taking. So speaking of dread taking, here are some test questions that I want you all to do. Oh, wow. Trixie, you said your teacher, she sings a lot and changes her voice and it distracts me. Yes. Yeah, well, you know what? Sometimes, Trixie, sometimes the acting that teachers do is to get the attention from the students who have a hard time deciphering it. But I'm glad you gave your teacher kudos, though. I know some teachers, I couldn't stand the monotone ones, the ones that just talk like this and they did not elevate their voice and they just kept it that way the entire time. We're going to have some inflections. Speaking of which, let's go ahead and get to question number 1. Which subatomic particle has a negative charge? I see 2 people that, want to jump ahead. That's all right. Electrons is correct. All right, very good. Number 2, what does the atomic number of an element represent? The number of neutrons, protons, electrons and neutrons, or protons and neutrons? All right. Very good. Those of you all that put B, you are correct. What if you put D? What would D be indicating? If you all put D, what would D indicate? Very good, Luis. Very good, Celebelle. Very good, Kendra. Very good, April B. Imali. Y'all are on point. Y'all are on point. All right. Now, look at number 3. Which particle contributes most to the mass of an element? Electrons, protons, neutrons, or electron cloud? Which one contributes most? And just so you know, it appears to be a tricky question, but I'm gonna put y'all over here on some game. Again, this is a formula guide that I created with General Chem 1 students in mind, as well as the basic chemistry students, because I wanted you all to have a colorful way to remember these things. If you take a look right here in the middle, protons and your neutrons in the middle, but majority of it is filled with your neutrons. Oh, yeah. Yes, I do, Trixie. They're on my website right now. Less than a cup of Starbucks, depending on which size you get. You're welcome. And let me tell you, I have everything from the metric system, and it's 11 by 17. So, I can't show the whole thing because it's that long. But it's 11 by 17. It's front and back. Okay, front and back. All right, what about number 8? Yeah, we already did this particular problem, but I want y'all to tell me what you think the answer is for number 8. It says an atom with 8 protons and 8 electrons is negatively charged, positively charged, neutral, or an ion. Now, let me tell you guys how to interpret this, because this is a tricky question. Okay. Oh, when you think about what they're saying, okay, you guys first of all think, what element is this? This right here is oxygen. Oxygen has an atomic mass number of 16, okay? And it has an atomic number of 8. But it has an ionic charge, okay? The ionic charge is equal to -2. So if it's -2, that means it is negatively charged. And no, you don't need to know. Nope, Celebel, I'm glad you asked that very good question. You do not have to know the mass number if you only look at the protons, okay? Because remember, the protons identifies the element, okay? The protons identifies the element. So if my protons identifies the element, okay, then if you had a periodic table on standby, it would be so much easier for you to grab that answer quicker. Yes, that's right, Emily, or please forgive me if I'm mispronouncing your name, but yes, that is correct. You have to look at the element that I'm referring to answer that question. Oh, yes, I got you. Okay, medical physics. Oh, I like that. Yep. So I know you deal with half-lives all the time. Like if you probably deal with technium, element technium, to deal with radiation and half-life. Technium 43. Yeah, I mean atomic number 43, yes, but technium 99. Yes, technium 99. That's one of those odd elements. All right, number 5. Number 5. Which part of the atom contains protons and electrons? Y'all should get this real quick. That's right, C. We talked about that already. Correct. C is correct. Number 6. If an atom gains an electron, it becomes a cation, a neutral atom, an isotope, or an anion. So I'm going to give you all the definitions in case you forgot. Anions are negative ions, which means and I'm going to tell y'all in a second, and positive ions, okay? So if you are negatively charged, that means you have the ability to gain an electron. And if you are positively charged, you have the ability to lose those electrons, okay? So the answer to number 6, if an atom gains an electron, that means it is an anion. So letter D. Letter D. Okay, I'm going to skip 7 because we haven't talked about isotopes yet, but this is a great segue in a moment. But let's get to number 9. We'll do talk about isotopes in a minute, but let's get to number 9. Number 9, the mass number of an atom is the total number of protons, neutrons, electrons, or protons and neutrons. All right. Yep, Millionaire Simone and Imali and Mercedes. And let's see. Yeah, all of you all that are putting D, very good, very good. You are correct. Remember, protons and neutrons are right there in the middle, okay, of the nucleus. But that's also how you get the mass number, okay? You have to add those two together, all right? D, if it was A, it'd be a different element. Right. That's correct. That's correct. Speaking of which, let's segue to that conversation. Celebel, I'm glad you brought this up. Isotopes. Isotopes. They have the same number of protons, but they have a different neutron because of the mass. So let me go back up here to my notes so you all can see that, okay? So I'm going to go back up here so you all can see what an isotope is. All right, so an isotope right here. All right, so what is an isotope? Whoops. An isotope is basically the element with different numbers of neutrons, okay? And because that's small and y'all can't see that, let me go ahead and make this large so y'all can see it. All right, there we go. So an isotope are atoms of the same element with different numbers of neutrons because of the mass number, having different mass numbers. So here is a classic example. You may have heard of carbon 12, right? Carbon 13, carbon 14. Well, when you look at the periodic table, which, speaking of which, right here, when you look at the periodic table for element carbon, right there, the mass number that you see, 12.01, that's equal to the average weight of all 3 isotopes. So let me give y'all another example. That way this will make more sense now. So let's say that you may be a twin, all right? So let's say element twin. I'm just making up an element, all right? Element twin 1 had a mass, when they were born, they weighed 8 pounds. Element twin number 2, the second child that was born, may have had a weight of 9. Well, the average weight that you will see on that periodic table is when you add these two numbers together. Let's go ahead and add them together so y'all can see that. 8 plus 9, and then divide that by 2, you get 8.5. So this would be the number that you all would see on your periodic table, okay? So this was a hypothetical element called twin. All right, you know how y'all be saying twin, you know, that twin energy, okay? So if you all were to see this on the periodic table, you would see 8.5, okay? So If you see 8.5, that's the average weight between those two. All right, between these two right here. So when you add 12 plus 13 plus 14, and then you divide that by 3, you get 13. But remember, the average weight of all three, because these numbers here are whole numbers, but if you were to look up their weights, they would be based on a certain number. So on your periodic table, the average number or the average weight of those three isotopes is 12.01. Now, why am I bringing this up? Because when we look at the protons, they're going to all be the same thing, which is the atomic number. Okay, if we look at our periodic table for a carbon, the atomic number for carbon is 6. So they're going to all have the same number of protons. But how they're going to differ are the neutrons because of the mass number. So I'm going to also put down the electrons. Okay, the electrons is again 6. Now, here's where it changes. My neutrons, okay? My neutrons. How does it change? Well, it changes because the mass number is different. So 12 minus 6 gives us 6. The neutrons for carbon 13 is 13 minus 6, so that gives us 7. And then the neutrons for carbon 14 is 14 minus 6, so that gives us 8. So as you can see right here, the mass number changes the neutron value. So that's what an isotope is. So if I told you to, again, give me the protons, electrons, and neutrons for an element, if it has an isotope, meaning a twin, or a third or fourth or fifth types of elements combined, then you're going to write the same thing for the protons and electrons, but what's going to change are my neutrons. Not all elements have isotopes, though. Okay, not all of them do. Only a select few do. Only a select few. All right, so down here, okay, matter of fact, let me see if I can find you a good example. Ooh, right here. Let's take a look at, okay, isotope notation. Yeah, let me say something about isotope notation, which is right here under part 2. See that part right there? Isotope notation. Isotope notation just simply means the key element that I told you, dash, and then the atomic mass number. So let me write this up here so you all can see that, all right? So isotope notation is written with the chemical symbol dash the atomic mass number, all right? And then this is the chemical symbol right here. So if you know that, here's what you're going to do. For this one right here, it says write the isotope notation for an atom with 6 protons and 8 neutrons. You're going to add those two together. What's 6 plus 8? That's equal to 14. That's the mass number that you're going to use. So I'm going to put that right there, the dash 14. I'm going to go to my periodic table and identify what has 6 protons, hence the 6 electrons. On my periodic table, the element that has 6 protons, 6 electrons is element carbon. So this right here would be written as the isotope notation for carbon-14. Thank you so much for sharing the live, guys. And also thank you all so much for the follows as well. If you take a look at so this is the answer right here. So I'm going to highlight it so you all can see that. All right. This is your answer right here. Number 17. I'm sorry, number 7. Number 7, sorry. Number 7. Write the isotope notation for an atom with 17 protons and 20 neutrons. Well, add those two together. You get 37. To identify what the element is, to put in this box right here, I'm going to look on my periodic table for element 17. So let me go to element 17. I'm going to let you all do this with me. What element here has 17 as the electrons and the protons? Put the symbol in the box, in the chat box. Very good. Yes, it is chlorine. It is chlorine. So Cl goes right there in the box. So to write that better, I would write Cl37. All right. So again, these problems do not have to be difficult. Yes, it is so much you have to remember, but guess what? That's the way it is. That's the way it is when you're getting your education in these different professions. There's a lot you're going to have to put to memory. Now, another type of notation here is what's called an isotope atomic notation. Atomic notation simply means the two A's. The two A's. The atomic mass number. Look, I can't even spell. Hold on. Atomic mass number. And on the bottom is the atomic number. So if I were to give you 2311 sodium like this right here, okay? This is, oops, sorry, y'all didn't see that. My bad. Right here, you would end up with the mass numbers on the very top. The atomic number is on the very bottom. And then this is the chemical symbol right here. Okay, that's the chemical symbol right there. So I'm going to do 2 more questions with you all before we end the live. But so far, does anybody have any questions about what we have discussed thus far? Any questions? Okay, so oh, good. Shenanigans 01235. You said you took chemistry 5 years ago. Okay, good. It's always good to get refreshers. All right, so we pretty much answered question 7 earlier. So in case you all just stepped in, we'll hit 7 and 8. We'll go ahead and hit 7 and 8. Number 7, which statement best describes an isotope? Same number of neutrons, different protons. We know that's not the case. Same number of protons, different neutrons. Same mass, different charge. No. Same electrons, different protons. No. The answer is B. Same number of protons, different neutrons. Different neutrons because of the mass number. Speaking of which, carbon 14 and carbon 12 differ in the number of what? Protons, electrons, neutrons, or valence electrons. Yep, neutrons is correct. Neutrons is correct. All right. So we're going to actually stop right here. We've been on here for an hour now. And what I'm going to do is tonight, I may be back on tonight. Yes, I may be back on tonight. So that for those of you that are like, you know what? I want to see this lady again. I want to get some more questions answered. Pull up tonight. Now I will post when that is so that you all will know, but make sure that you all bring a friend back. Okay. Don't be a stranger. Bring a friend back. All right. Bring a friend back. So to close this out, we'll do 10 and 11. Since there are 9 people now, we're going to do 10 and 11. All right. 9, 10, 11. All right. Number 10. Which subatomic particle is found outside the nucleus? Now, I said this before. This is on my guide here. All right. So if you all want it, it's okay. Honey, we'll get to stoichiometry. Woo. Stoichiometry usually doesn't take place until right before spring break. And spring break for us is around... It's the first week in March, but, are you taking the TEAS exam soon, Imali? And I also have plenty of videos on stoichiometry too. Yes, electrons is correct. Yes, electrons is correct. Because you know your protons and neutrons are right there in the middle, but on the outside having a good old time are your electrons. So C. And number 11, an atom with 11 protons and 10 electrons has a charge of what? This is tricky. Okay, Molly, well, you know what? Go to my YouTube channel. I've got plenty of questions for you. And I have plenty of videos, rather, on stoichiometry. And also, I have a playlist here on TikTok, too. If you have 11 protons, but you've got 10 electrons, what happened here? Did we add a charge or did we take away a charge? So you know it's not going to be D. You know it's not going to be B. But it's between A and C. You're welcome. You're welcome. Now, remember, what's changed here are your electrons. So if you had, if you initially had 11, electrons, and then all of a sudden it dropped to 10, okay, that means in chemistry, if it was positive, that means you had to drop it down, okay, by 1. So in this case right here, that means you had letter C. That's right. Good job. I'm glad y'all did not get tricked up with this one. It is C. And here's the reason. Because remember, even though you start off with 11 and it dropped to 10, you know that there's a positive charge. That means I have to deduct or subtract 1, all right, to get the 10. So the charge has to be positive. But a quicker trick is to look at the element. 11 protons tells me that this is element sodium. Right here. And sodium has a positive 1 charge. All right. You guys were awesome today. Awesome, awesome, awesome. So I look forward to seeing you guys tonight. If you all want to come back through tonight, I will be here at, well, the time, let me see. It's between 6 and 7:30 and 8 o'clock. All right. But I will post when that time will be so that you guys will know. All right. Thank you guys so much for joining me this afternoon for my lunchtime chemistry special. I look forward to seeing you guys again. All right. Take care. Oh, yes. Eastern Standard Time. Yes. I'm on Eastern Standard Time. Yes. All right, guys. Y'all take care. Stay warm. If you are anywhere where it's cold, stay warm, stay careful, and take care. You're welcome. You are welcome.